Hello everybody, welcome to Anushka Tech YouTube channel. So in the previous classes we have discussed what are trigonometric ratios, we have defined them, and also we have solved a few problems related to trigonometric ratios. Okay, so in today's class I will start with next bit, that is trigonometric ratios of some specific angles. Okay, so we'll study what trigonometric ratios of some specific angles. Okay, so trigonometric ratios of some specific angles. See, we are not studying almost all the angles, we are studying only few specific angles. Like, so we are almost familiar with the construction of angles like 30 degree, okay, then 45 degree, 60 degree, and 90 degree, of course, and we'll also find the value for 0 degree. What will be the trigonometric ratios when the value is, our angle is 0 degree. Okay, so let's start with the first one, that is we'll start with 45 degree. Trigonometric ratio trigonometric ratio of or for 45 degree. Okay, so when the angle is 45 degree, what will be the value of the corresponding trigonometric ratios? For that, what we need is again a right angle triangle. So let us draw a right angle triangle called as A B C, which is right angled at B. Okay, now let us take angle A as 45 degree, because we are supposed to find trigonometric ratios for 45 degree, right? So if I take angle as 45 and angle B is 90 degree, then angle C will also be how much? It will also be 45 degree. That is angle sum property of a triangle. Sum of all the angles is equal to 180 degree. So when these two angles are equal, it implies that the side AB is equal to the side BC. That is a property of isosceles. Okay, since what? Angle A is equal to angle B, BC is equal to AB. Now since we don't know any side of the triangle, because they have not given any side, so let us assume that, or we'll take a value of BC and AB is equal to some constant as K. Okay, it is some letter of an alphabet K. So let us define the sides as K and K. Now we have to find the hypotenuse, that is AC. Again we will apply what? Pythagoras theorem. We know that by Pythagoras theorem, AC square is equal to AB square plus BC square. Okay, so AB value is K square and BC value is also K square. It becomes 2 times K square. So therefore AC is equal to what? K times root 2. Then if I take square, if I shift the square to the RHS, it becomes square root, and in that square root K will come out, so it will become K, it will be root 2. So this is what? K root 2. Okay, now we'll define all the trigonometric ratios. For that we should be knowing, or we should remember the definitions of trigonometric ratios. So let's start with sine. So sine 45 degree, we'll write 45 now instead of A, and this is our angle of reference. So sine is nothing but what? Opposite by hypotenuse. Okay, it is BC by AC. So what is the BC value? It is K, and what is the AC value? It is K root 2. K and K will cancel, so we are going to get sine 45 as 1 by root 2. Next is cos 45 degree. So cos is nothing but adjacent by hypotenuse, so that is AB whole divided by AC is equal to again K divided by K root 2. K will cancel, again we are going to get same 1 by root 2. So next is tan 45 degree is equal, we can now write tan as sine by cos, or else we can write it as opposite by adjacent. So that is BC divided by AB. So what is the value of BC? It is K. What is the value of AB? It is K. K and K will cancel, so we are going to get tan 45 as 1. Now similarly we will write all their respective reciprocals. So reciprocal of tan is cot So cot 45 is 1 by tan. So that is 1 divided by tan 45. So already tan 45 is 1. So cot 45 is also 1. Next, sec is the reciprocal of cos. So sec 45 is equal to 1 by cos 45. So cos 45 is how much it is? 1 by root 2. So this root 2 will go to the numerator. Done. And last one is for sine. The reciprocal of sine is cosec. So cosec 45 is equal to 1 divided by sine 45 degree. Same again, it is 1 by root 2 will be is equal to root 2. So these are what respective trigonometric ratios when the angle of consideration or reference is 45 degree. Now we'll write them in a box. Okay. So sine 45 we got it as 1 by root 2 comma cos 45 is equal to 1 by root 2 comma tan 45 is equal to 1. Below we'll write the respective reciprocals. Cosec 45 is equal to root 2 comma sec 45 is equal to root 2 and cot 45 is equal to 1. So this is how we found what the trigonometric ratios for a specific angle of 45 degree. I hope everybody is clear regarding this what 45 degree. So nothing, we have to just make the side AB and BC as equal, because when one angle is 45, another is 90, the third angle will also be 45 degree. When these two angles are equal, their sides will also be equal by the isosceles property. And we have, since they have not given any side value, so we have taken the side of length of each side as k, and we have calculated all the trigonometric ratios. Okay. So next we'll go with second one, that is trigonometric ratios of 30 degree and 60 degree. Okay, we'll do it combinedly. We'll find trigonometric ratios of both 30 degree as well as 60 degree. For that, what we'll do is, now we'll take we'll draw an equilateral triangle. So an equilateral triangle is the one whose all angles are equal, that is they are 60 degree. Okay, all the angles are how much? 60 degree. So ABC is our equilateral triangle, and in an equilateral triangle all the sides will also be equal. AB equal to AC equal to BC, all the sides are equal and their angles are also equal, that is 60 degree. Now what we'll do is, we'll draw a perpendicular line from A as AD on the line BC. Okay, it will cut the line BC exactly at the center, and AD is what? It is a line perpendicular to BC. Perpendicular means obviously D will be now 90 degree. Okay, now we are having two triangles, that is triangle ABD and this triangle ABD and triangle ACD and triangle ACD. Now both the triangles are congruent because these two sides are equal, right? This is the common side, and this the line is being intersected or cut at exactly at the center. So these two sides are also equal, and these triangles are equal, and these two angles and these angles are also equal. So they are what? Triangle ABD is congruent to triangle ACD. Done. So now this is what? 60 degree. So when this is 60 and this is 90, obviously this has to be 30 degree. Okay. So we'll consider a triangle ABD. In this triangle we are going to find out the trigonometric ratios for 60 degree as well as 30 degree. So before that, again they have not given any length of the side lengths of the triangles, so we need to define them. Let us take the side lengths, that is, let what AB is equal to BC is equal to AC. Let us take it as 2A. Okay, we'll define each sides as 2A. So this is also 2A, and this entire value is 2A. What about BD and DC? They will be exactly half because they are at the midpoint of the line BC. So BD value will be only A and DC value will also be A, that is half of BC. Okay, now we'll start with then this is a triangle. We need to find this particular side, that is we have to find AD. We know now AB and we have BD. We need to find out AD again by Pythagoras theorem. For triangle ABD, okay, by Pythagoras theorem, now what it is, AB square is equal to BD square plus AD square. Okay, already we know AB value. AB value, it is how much? 2A whole square. What is the value of BD? It is A square. We don't know what is the value of AD, right? So we need to find this. Therefore AD square is equal to 2A whole square is nothing but 4A square. When I shift this towards 4A square, it will become minus A square. So this is 4A square minus A square is simply 3A square. Then AD will be square root of 3A square. Now A square will come out of the square root and it will become A root 3. Okay, so we got the side AD as A root 3. Done. I hope this is clear. We found all the sides. Opposite side is how much? Okay, now we should be very much careful. First we will determine or we'll find the trigonometric ratios for 30 degree. Then we'll go for finding it for 60 degree. Done. So when we take angle of consideration as 30 degree, then this becomes opposite side and this will be the adjacent. Okay, and when I take 60 degree as angle of reference, this becomes opposite and this becomes adjacent. Done. So what we'll do now is we'll find for 30 degree. Okay, so we know by definition that sine 30 degree, I hope you remember. Now this is the angle of reference 30, right? So this will be the opposite side, BD divided by AB. What is the value of BD? It is A. What is the value of AB? It is 2A. A will cancel, so it will be only 1 by 2. Next is what? For cos 30 degree. So cos 30 is now this is what? The adjacent side, that is AD whole divided by opposite is, sorry, hypotenuse is AB. So AD is how much? It is A root 3 whole divided by AB is how much? 2A. AA will cancel, we are going to get only root 3 by 2. Now similarly for tan 30 degree. So tan 30 will be what now? This is what? Opposite side, that is BD, and this is the adjacent side, that is AB. So BD is A divided by AB is A root 3. AA will cancel, so we are going to get as 1 by root 3. Okay, so similarly the reciprocals, it is cot 30 is simply 1 by tan 30 is equal to 1 divided by 1 by root 3 is equal to what? Root 3. Now for sec, that is reciprocal of cos, it is 1 by cos 30 is equal to, that is 1 by root 3 by 2 is equal to 2 divided by root 3. And lastly cosec, which is reciprocal of sine, 1 by sine 30 is equal to 1 by 1 by 2 will be equal to 2. Okay, now let's tabulate them. We found all the trigonometric ratios when the angle is 30 degree. Sine 30 is how much? 1 by 2. Then cos 30 is equal to root 3 by 2. Tan 30 is equal to 1 divided by root 3. The next is reciprocal of sine is cosec. Cosec 30 is equal to 2. Reciprocal of cos, that is sec 30 is 2 by root 3. And lastly reciprocal of tan is cot. So cot 30 is equal to root 3. Okay, so we found the trigonometric ratios for the angle 30 degree. Done. So what we are supposed to do next? We are supposed to find out trigonometric ratios for 60 degree. Okay, so we'll consider again the same triangle, because we have defined everything here only. Now let us go for 60 degree. Now when we say 60 degree, only what is going to interchange is opposite and adjacent. So let us start now. Sine 60. So sine 60 is equal to, see, now this is the angle, right? This will be the opposite side and this is the adjacent side. It is equal to AD divided by AB. So what is the value of AD? A root 3 whole divided by AB value is 2A. AA will cancel, so it will be root 3 by 2. Next is cos 60 degree. So cos 60 is adjacent, that is BD divided by AB. So BD is A divided by 2A. This will be 1 by 2. Next is tan 60 degree. So tan 60 is AD divided by BD. That is A root 3 whole divided by A. AA will cancel, it will be root 3. Now let's write the reciprocal. Reciprocal of tan is cot. So cot 60 degree is equal to 1 by tan 60. It is equal to 1 by root 3. Now next reciprocal of cos is sec. So secant 60 is equal to 1 by cos 60. This is equal to what? 1 by 1 by 2 is equal to 2. So next is cosec, that is reciprocal of sine. Cosec 60 degree is equal to 1 by sine 60 degree. So this is equal to how much? It is 1 by root 3 by 2. So this will be 2 by root 3. Now let's tabulate them. Okay. Sine 60 is equal to root 3 by 2. Then cos 60 is equal to 1 by 2. Then tan 60 is equal to root 3. Then cosec 60 is equal to 2 by root 3. Then sec 60 is equal to 2. Then cot 60 is equal to how much? 1 divided by root 3. Okay. So this is what trigonometric ratios for angle 60 degree. Now one thing you can observe here is sin 30 is 1 by 2. Here cos 60 is 1 by 2. Okay. Sin 30 and cos 60, they are same. Here cos 30 is root 3 by 2. Sin 60 is root 3 by 2, right? So cos 30 and sin 60 are same. In this way you can remember what? Sin 30 is same as cos 60. Cos 30 is same as sin 60. Okay. So with this we'll conclude today's class. We'll meet you in the next class with the further problems. Thank you.